Alright, so today we're doing gravitation. I've got the warm-up up there in case you want to see how I solved it. But we've done gravity before. We got, are you paying attention? They're always hearing your name on this video. Pay attention, please. What was I saying? Yeah, we've done gravity before. We've calculated the weight of things. That's a gravitational force. And like what we've done has been just for Earth. We've used the acceleration due to gravity on Earth to calculate our weight on Earth. We just got to do mass times acceleration, F equals ma. And we can do that same thing like we've done that with the moon. We used negative 1.6, I think is what the moon was. We used a mass on our moon, our mass on the moon, to multiply by negative 1.6 to find our weight on the moon. But what if you wanted to calculate the gravitational attraction of the Earth to the moon? Would you use the moon's gravitation, or the moon's acceleration due to gravity, or the Earth's acceleration due to gravity? You can't really use F equals ma with that, and that's why we're using this different formula with it. So, let's see. Yeah, that's fine. So I'm going to use myself here. Hey, this marker works. How about that? All right. So yeah, change the question there. I'm going to calculate how much I would weigh on Earth in newtons. So this gives you a new formula. Now, our formula uses a constant, and the formula is up there, but I didn't want to zoom out that far, so I'm going to write the formula here. So gravitational force equals this constant, and then there's two masses, mass 1 times mass 2. Those two masses are the two masses that are being gravitationally attracted. So if you're trying to find the gravitational attraction between the Earth and the Moon, m1 would be the mass of the Earth, m2 would be the mass of the Moon. Or, like I'm doing me and the Earth. So the gravitational attraction between me and the Earth, that's my weight, is I'll put my mass there and the Earth's mass there. And the last thing in the formula is this r down here. So that's going to be, that's r squared. Oh, excuse me. Yeah. That's going to be the distance between the centers of each object. So in the Earth and the Moon, this is between the center of the Earth to the center of the Moon. So in that case, you'd have to take the distance between the Earth and the Moon and add the radius of the Earth and the radius of the Moon, and then that's the distance between the center of each object. And in my case, it's the distance from me to the center of the Earth. This 1 meter between my center of gravity and the center of the Earth does not make a difference as far as the radius of the Earth goes, so I'll just put the radius of the Earth down there. So let's try it out. So, calculating my weight. That gravitational constant is that 6.67 times 10 to the negative 11. I'm not going to write that huge unit. That's all that is units. Because you have mass and mass up here, it's kilograms times kilograms, and then meters times meters down here. So it's kilograms squared over meter squared, and then there's your newtons over here. This has those kilograms and meters and newtons just to make everything cancel, so you're not left with leftover units after you plug in the constant and everything else. So this isn't anything to plug in, that's just the unit for the constant. So what I got? I got my G. My mass is 85 kilograms, I guess. The Earth's mass, got it right there, 5.98 times 10 to the 24 kilograms. And the Earth's radius I don't know if y'all can see it. It's kind of way up there. 6371 008. And I was so specific with it because I got a Mount Everest question in there, if y'all get to it. And that's squared. That's meters. And if I calculate all that, I calculated this before, and I got 835 newtons. Let's try it the regular way. Let's see if one of these other markers work. How about this one? Let's calculate my weight just with F equals ma. That's a different one. That's a different color than my other green marker. Weird. So if I'm doing that, I'm still 85 kilograms. I use negative 9.81 there. There's some kind of rounding going on with these constants or the 9.81 or something, because this was 835 and this one I ended up getting 834. But you can see these calculate the same thing if you're doing a person on the Earth. But if you're doing a person on a planet that you don't know the acceleration due to gravity, or if you're doing between the planet and a star or between two planets, this is the only formula you can use. Anyway, there's a few questions with this. Please go try it out, I believe. Any questions? All right.